Hi guys, this is the extra lesson for 10th graders for second semester first exam. Now we will be solving some questions that I shared from the site as PDF. So my voice can be bad, but now it is in, then it will be bad again. Right now we are talking about voice, how it sounds. Yes, is it good, Ama? There might be boom, 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 boom. Is there? Why is it doing it? What about now? Is it same again? After this moment, is it same again? After you see this writing over there, listen my tone, my voice. Okay, let's continue. Let's not care about the voice anymore. Is it good now? Let me listen myself. Oh, it's very bad. The voice is very bad. I should arrange something else. There is also something with cable. I'm on inside. Let's start the extra lesson. So let me check the comments from here from time to time. You listen me from here now. You can remove it. You listen me from here, not from the headphones. So right now 3 people is watching. 1, 2. Who is the third one? No. You think I? So Edison is watching. I am watching myself. So. Ama, this is not for 9th graders. This is for 10th graders. The voice is wonderful. Who is that? I. Ama who is Mirant Malinci? Mirant Malinci probably Sabriya. Sabriya. No, brother of mine. And I made my money. Really? Yeah, yes, yes. Surname was. Okay, anyway. So the first type of things that multiplying the polynomials, this is something easy. Or let me change this question. This question we already did in the class. Let's write another question which is similar to this one and lots of powers in it. Let's say x squared plus 2x. I think I asked something like this in quiz. And then 3x squared, not plus minus 5x minus 4. Let's try to multiply these two things. So when we multiply polynomials, we should multiply each thing inside of first by each inside of the second one. So the first times first, first times second, and first times third, we should do that. Second with first, second with second, second with third, we should multiply them all. After that, we add and subtract the similar ones. So first by first, x squared times x squared, 3x squared will be the coefficient part is 3x squared times x squared is going to be x to the power of 4. So then x squared times minus 5x, first take the coefficient part will be minus 5x minus 5, then x squared times x will be x cubed. So then x squared times minus 4, first times the last one is going to be minus 4x squared. Multiplying with the first is finished. Now we are going to multiply by the second. Second with the first. 2x times 3x squared. So firstly the coefficient part, the number part. 2 times 3 is 6. So right now should we put plus or minus? So it is positive 2 in there. It is positive 3 in there. So plus 6. Then later part, x times x squared is going to be x cubed. Then second with this, plus 2 times minus 5 is minus 10. So you don't need to worry about that. It's minus 10. Then x times x will be x squared. So then plus 2x times minus 4 will be minus 8x. Right now, multiplying part is finished. We did multiply everything with another one with the parentheses. So let's look for the same things. Here we have x cubed, another x cubed, minus 5 plus 6. Of course, firstly, we should write the biggest power, x power 4. So then plus minus 5 will be plus 1, x cubed. So then x squared minus 4 minus 10 x squared makes minus 14 x squared. So then I used this one, I used this one. So I did use them also. There's just minus 8x to move it in this place. So now, let's go to the next page. So you are writing, let's wait for you to write. And then right now, we have just 2-3 people, which is good. How can I share the link of this one to somewhere else? Is there something like this? Yep, in here. I'm waiting for them to write. Yes, they are writing. Actually, it's not so needed to write. Um, what? Yes. Hello. Yes, we started. We have one more people. How can I go to comments part? I think just close the comment part. I should close and open again perhaps so I can see the comment part. Yes. Put absences. Okay, I will put absences. So now, the next thing, I think this part you all wrote. Actually, there is no need to write because you can watch it again. After we finish this lesson, this video will be in YouTube, so you can watch this again. So now the next question type, it's again the same things. Multiplying two polynomials, multiplying, then later subtracting. So it is similar with the first one. And let me show you this one. For example, it is 2x squared times, you will write all the polynomial px in here, 2x cubed plus x minus 3, then you will multiply this. So in here, like, it can be mixing like 2 times 2, 4, x squared, x cubed, x to the power of 5, 2x squared times plus x. So when there is no number, just only the number part, just plus 2 in here, x squared times x, the latter part will be x cubed. So then 2x squared times minus 3, we decide this plus and minus by looking result of product. 2 times minus 3 makes minus 6, so we put minus in here. So then there is no letter part in here, so it's just x squared. I mean, you can do the rest, I think, on yourself. So we did one example in here about this. It should be enough to remember this, I hope. So let's find another type of example from the exam questions PDF. So this is the next type of dividing polynomials. Is there anybody who remembers this one? Yes, Uran remembers, but I should turn off the sound in here because I am hearing my sound from headphones. So right now we decreased to 3 people at this one. You, me, and Ayit. You're watching this one. Anyway, who cares? Let's move on. This is the type of division that if you have just one thing in denominator, just one thing in denominator, one term in denominator actually. So let's do the one which seems like hardest one. So if you have just one thing in denominator, you separate them. In every place, you write the same denominator. You write the same term. So over there, the first term is 6x power 4. I put minus in here because there is minus over there between them. Then x, 8 times x squared. So then this is simple division. Firstly, you try numbers. 6 over 2 is 3. If you can't divide, you leave 6 over 2 like that. So then you look for letters, x power 4, x power 2. When we divide with exponentials, we subtract their powers. 4 minus 2 makes 3x squared. So then minus between them, 8 over 2 makes 4, x squared, x squared. Simplify each other, times 1, no need to write. So this is not the one which is confusing. The confusing one is the next one, which is this one. So, did I ask this one in quiz? Did I ask this in quiz? Yes. That means it may not be in the exam. I don't remember what I put in exam, what I asked in exam. I really don't remember. So should we solve this one? What do you want? Let's solve this one. How do you solve this one? Let me show you this one. Height. Eh? So let's do one type from each thing. One type from each thing. Just one from each type. So let's solve this one. So we put this like we are dividing normal numbers. And then 2x minus 3 equals. So then, so when you put a number in here, like 3, 4, 5, you should multiply this number by 2x minus 3. After that, you should subtract it from other side, like normal division. So in normal division, you look for the leftist one. You start from left side in here. So you try to make equal to this number. So we will multiply something with 2x and minus 3 is additional part. 2x is the big one. The big one should be same with the biggest one. So 2x should be same with the 6x cubed. So I must multiply 2x by which number? So it can be 6x cubed. First say the number part. 2 times which number is 6? 2 times 3. Then letter part. X times what makes x cubed? X squared. So then, let's multiply. 3x squared times 2x makes 6x cubed, the thing that we want. But we also need to multiply 3x squared by minus 3. So it makes minus 9x squared. 3 times minus 3 makes minus 9x squared. So then we should subtract this polynomial from upper side. So subtracting means minus times 6 is going to be minus. Minus times minus 9 is going to be plus. We write the new signs over there with smaller type, with smaller size. So 6x cubed minus 6x cubed is 0. Minus 11 plus 9 is minus 2x squared. So the first step is done. We should continue by moving other things, 13x and minus 7. Right now, the biggest one is minus 2x squared. Here I have 2x. So I should make 2x into minus 2x squared. Exactly same. So 2 times minus 1, I need 2 times minus 1. And then to make x into x squared, 1x. I need minus 1x in here. I decide by looking the big one in here. The big one should be same with the biggest in here. So minus 1x times 2x. Minus 1 times 2 is minus 2. X times x is x squared. We should also multiply minus 1x by minus 3. Minus 1 times minus 3 is plus 3x. So then subtract it. So minus will change the signs in this row. Minus times minus will be plus. We write it with a small size. Minus times plus will be minus. We write the new signs with a small size in here, so we don't make mistakes. Minus 2x squared plus 2x squared, 0. Plus 13x minus 3x is plus 10x. And then we have minus 7 over there in this place. So the next step, the second step of division is finished. We look for, can we continue anymore? Here we have 2x. From 2x, can I get 10x? Can I get 10x? So by multiplying by 5. So if I write here just plus 5, 5 times 2 is 10x, 5 times minus 3 is minus 15. Let's subtract them. So we should write the new sign. Minus times plus 10 is minus 10. Minus times minus 15 is plus 15. Plus 10 minus 10 0. Minus 7 plus 15 is plus 8, huh? Okay. So right now, can we continue anymore? 2x times something, does it make 8? Is there any chance? So 2x times 4 makes 8x. It is not 8. So this calculation is finished. We have remainder 8 and quotient 3x squared minus 1x plus 5. So actually this is not something hard. You just need to do it slowly. When you want to do it like quickly, you may do mistakes. You might do mistakes. Yes. One more watch. What's that? Teacher, does it matter if I don't write one? Yes, it does not matter. It's not big deal writing one in here. Actually, it mustn't be written minus one in here. But I wrote it so you can see it better. You can understand it better. That's why I wrote the minus one. Normally, we don't write that minus one in there. So this is very good. That means how many people here we have right now? 6 watching. Bildaran, is it turned on right now? Yes, that means 1, 2, 3, 4 is in the class right now. We are listening at the same time, watching from the phone at the same time. That means 2 more I than Venus over there. So let's move on. So this is similar type of examples. I will not be solving this one. Division, dividing. This is also similar. Here, the big one is 2x squared. In the first step, let me tell you the first step only, which is from 2x squared, we will try to get 8x to the power of 4. So we are going to multiply 2 by 4, x squared by x squared. So 4x squared times 2x squared will be 8x to the power of 4. There was the interesting thing in here, which is 4x squared times plus x will be plus 4x power 3. So when you subtract them, there is no cube in here. So you will write like minus 4x cubed. You do it like 0 minus 4x cubed makes minus 4x cubed. Then you move 4x squared minus 2x. That was the interesting thing in this example. If there is no x cubed up there, you just copy it down in here, like 0 minus 4x cubed. And this is also very same examples from different places. So this is the naive type of example. Find the remainder. Find the remainder. Do you remember this type of examples? This type of examples? No, I don't think that you remember. Firstly, let me try to explain you this idea. Yes, you remember. This was very easy example, easy type. So when I was in your age, I wasn't able to memorize the path, the way, the steps in here. So I kept it in my mind with the logic, which is when we divide px by qx, there will be a result in here which we don't care, and there will be steps over there and remainder. Do you understand this? Something like that will happen if we do normal division. Do you understand this? What I am telling? Do you understand this writing in here? No, no comment. So we are dividing px divided by qx. There will be result part, let's say n. We don't care what it is. And there will be remainder. Actually, I want to find only this one. So if we convert this into the equation form, px is the biggest one. You multiply these two things, qx times m, and plus the remainder part. So to be able to find this remainder, we are trying to make this part equal to 0, which is px will be equal to qx is x minus 2 times m plus r. How can I make this part equal to 0? If you put instead of x number 2, 2 minus 2 will be 0 times m, 0. 0 times anything equals 0. So to get rid of this part, when this part is equal to 0, that means the rest will be just a remainder. We understand that when we put p of 2 in that, we will be doing 2 minus 2 times m and plus r. This means, this equation means that whatever you put instead of x, they will always be equal to each other. So I can put any number I want. So to be able to find the remainder, I am putting exactly the number 2 instead of x. This equation says that it must be equal to each other. P of 2 equals 2 minus 2, 2 minus 2 times m plus remainder. I really don't know what is m and what is remainder right now. 2 minus 2 makes 0. 0 times m, so m goes away. You don't have to find it. That means p of 2 will give us the remainder directly. So let's use that. P of 2 in real polynomial. 2 to the power of 4 minus 2 times 2 to the power of 3 minus 3 times 2. So this is going to give us the remainder directly, which is 16 minus 2 times 8 minus 6. So 16 minus 16 will be 0. The remainder, that means, has to be minus 6. So the quick way that you were doing, let me show you in another example. I think I have one example that I didn't solve in the class. I think this one. Let's do this one. Is it the same example? Yes, it is the same example. I have copied it from Mr. Ahmed's plan. This example, I didn't do this one. Look, the quick way that you are doing in exam, in quizzes, that you say, if I am dividing this by x plus 1, so whenever x plus 1 is equal to 0, that number will give remainder. So you say that I just put p of minus 1, which is in this formula. Let's do it in here. I don't have placeholder in that. I'm going to put p of minus 1 in here, so it's going to give me remainder minus 1 plus 2 power 5 plus 2 times minus 1 squared. Minus 1 squared. Later I will check that one. And plus 7 times x is minus 1 and plus 4. So minus 1 plus 2 is plus 1, power 5 is plus 1, plus 2 times minus 1. When you make them together, it makes minus 2, power 2 is positive 4. 7 times minus 1 is minus 7 and plus 4. 2 times 4, 8. 8 minus 7, 1. 1 plus 1, 2. Plus 4, 6 is the remainder. Let's check the comments. I wrote something? Qx. X is yes. She found the answer before I am telling. This one, I think, huh? I did it for this one, but this was exactly the same question that I solved in the previous time. So this is easy type of example. So this is getting harder when there is divided by x squared. Where is that? Also divisible. I will come back to divisible later. When there is x squared, this example is getting a bit harder. Actually, it's not so hard thing. I think there was a question in here that I changed one letter for it. Did I change? Was it this one? Perhaps it was this one. No, I think it was like 9s, 8s in there. This looks very hard. Let's solve this one. Is it okay? This is looking very hard. Actually not hard. Don't tell to anybody. So we want to divide this garbage thing, lots of x's in there. We want to divide it by x cubed plus 2. How? Sorry. This is not remainder. Let's qx. Let's change this question. into find the remainder. I want to solve a question in this time. That's why I'm doing. So actually it was the same. It writes in here on the top. Find the remainder when it is divided by this. Sorry. It is the question that I want. Very hard question. Very hard question. So we want to divide this big thing like x cubed plus 2 and find the remainder. So it was the similar step. So in the quiz exam, you don't show the other thing like qx divided by x cubed plus 2. There will be result, remainder. So you don't show like that. You directly do the solution with the method that I showed, which is this one should be equal to 0. That means to be able to find the remainder instead of each x cubed in the rule, in the formula, or however you say, instead of each x cubed, I'm going to put minus 2. Yes? Is she asking a question to me? Teacher, are you going to save this? Because yes, I will save this one. So whenever I finish, after like 10 minutes, you will be able to watch this video at any time you want. So now, let's come here. So in this here, we don't have x cubed. We have lots of big powers. So we will turn them into the x cubes. So 18, can I divide 18 by 3? Yes, we can. 18 divided by 3 makes 6. So I can change this into the x cubed power 6. So 3 times 6 makes 18. Plus 3 times 14. Can we divide 14 by 3? No. So we look for what is the number before the 14 and divisible by 2? 13? No. 12? Yes. So I can divide x power 12 by 3. So after 12, I will need two more. I keep it there. So from 14, I separate two somewhere else. So I'm gonna work like there is x12 right now. So it's x cubed power 4. So understand that in this term we have x to the power of 3 times 4, 12, plus 2 more from here makes 14. It is exactly the same thing. So right now let's continue with the further thing. Next thing, x to the power of 10, 10 I cannot divide by 3. So I think about what is the number before 10 and divisible by 3? 9 itself. So I'm gonna working with 9. I will work with 9 in here. So I need to put x power 1 somewhere else. So how can I change 9 into x cubed? X cubed to the power of 3. 3 times 3, 9, plus 1 more from here. It is same with x to the power of 10. So from big powers, we are trying to get x cubed. What is the idea? We want to get x cubed, so we look for before 10, which number is divisible by 3? Before 14, which number is divisible by 3? 18, directly divisible by 3. So now let's continue. Oh, these are small powers, very good. 7x cubed plus 5x squared plus 2x and plus 3. Right now, instead of each x cubed, I am going to put or replace minus 2. X cubed is minus 2 power 6 plus 3 times x cubed is minus 2 power 4 times x squared. We cannot do anything with x squared. It just stays like that. 4 times x cubed is minus 2 and power 3 up there times just x. I removed the power 1 in there. So 7 times minus 2 plus 5x squared, I can't touch it. 2x and plus 3, I can't touch those things. I am doing only this. Wherever I see x cubed, I put minus 2 for it. Now we will finish everything. I hope just 2 steps more. Calculation. Minus 2 power 6. It is even power, so it will be positive. 2 power 6. Let's calculate this. 2 times 2, 4. Times 2, 8. Times 2, 16. Times 2, 32. Times 2, 32 times 2, 60. In here. Plus not plus, or be careful. Minus 2 power 4 will be positive, so we can keep the plus. 3 times 2 power 4, 2 times 2, 4, times 2, 8, times 2, 16. X squared. Minus 2 power 3 will be minus times plus minus. 4 times 2 cube is 8 times x. Not plus, 1 plus, be careful about that. 7 times minus 3 is minus 14. And plus 5x squared plus 2x plus 3. Let's finish this calculation for all. Let's be quick. So right now, what kind of x things do we have? We have x squared, single axis, and number parts. Firstly, let's look for x squared. 3 times 16 makes 48. I have 48 squared in here. Is there any other? 48 plus 5 makes 50. 3x squared. So now I finished with x squared. I'm looking for the x thing. 4 times 8 minus 32x I have from here. Minus 32x, this is just number, minus 32 plus 2. Minus 32 plus 2 makes minus 30x. So then the last parts, which are the numbers, the constant numbers, 64 minus 14 makes 50. 50 plus 3 makes 53. Now we finish this very hard question. If you would try to solve it with the old method, you would write lots of things under each other. Since you start with 18, after 18 it would be 17, then 16, then 15, then 14. Too many steps you would do. I should read something from here, from comments. Let's check that. Is it any problem if we do x cubed instead of x cubed to the power of 4? So there is no problem with that. So if you can't get this one, so one of the students wrote that in here x cubed to the power of 4. She couldn't understand how it happened. So we want to separate x to the power of, which one was that? It was 14. Okay. We want to separate x power 14 into the x cubes. How many x cubes can I get from here? So she starts like x cubed times x cubed. Now it is 6 times another x cubed. Now 3 plus 3 plus 3, 9 times another x cubed. 9 plus 3, 12. Now it is 12. To make it 14, we need x squared more. Later, you can put, instead of each x cubed, minus 2 times minus 2 times minus 2 times minus 2 and times x squared. Don't change that one. You can do like this also. This is open form, long way, and this is shortcut method. So this is like finding the remainder. We also have the types of questions. What's that? Divided, not this one. Divided, not this one. Not this one. Come on, where is that? Divisible. Divisible by x minus 3. So, if it is saying divisible by x minus 3, that means remainder. There is no remainder, which is the remainder should be 0. If it is saying is divisible, is a factor, that means remainder is 0, no remainder. So you will do it like finding the remainder. To be able to find remainder from here, x minus 3 equals 0. Instead of x, I should put 0. So let's name this polynomial as P3. When I write P3, it should give me the remainder, which is 0. Let's put 3 instead of each x in here. It is x cubed in the beginning, and plus 5 times x squared plus x minus k. So this should give me the result 0. Since it is divisible, no remainder. Remainder is 0. 3 cubed, 20. 7. 3 squared is 9 times 5. 45 plus 3 more and minus k. Let's put minus k in here as a single k. What a calculation do we have in here? 27 plus 3 makes 30 plus 45, 75. What is that? We can do that one. So, right now there is no more comment. Huh? Can you solve a question of product of the roots? Okay, from the last pages. I will go to the last pages, but I will go like step by step. We are like in 14th page. Or let's go from here, from the laptop. It will be faster for me. 17. So, for example, you may try these examples on your own to try yourself. I also put these things like Mr. Ahmed gave them as homework to his classes. Opening things, are you good with this? Should we do this one? How do we open? With power 2, with power 3. These are very basic and very important. Yeah. 2a minus 3 minus 2a plus. No, this is power 2. I will explain them. You will explain them later, huh? Or should we do one like this? Okay. Let's do one like this. Let's change this question into something else. Let's make it very hard question. I'm gonna make it 5a minus 7b squared. I made it very hard, very big numbers I used. So guys, actually this is the rule that you have written. We have written like a plus b squared, a squared minus 2ab plus b squared. Or a minus b squared, a squared minus 2ab and plus b squared. If there is plus 2ab, if there is minus 2ab. What this, actually this is not like a and b, this is like first and second. Square of first plus 2 times first times second and plus square of second. We continue like that. Or if you can't memorize this one, with power 2 you can use, if you can't memorize, if you mix your mind a lot, if you can't remember the rule. For this example, you may do 5a minus 7b times 5a minus 7b. You can do this, which is first with first, first with second, second with first, second with second. This is long and unnecessary, but chamebo if you don't remember the rule. Yes. Is there a question for me? Comments? No? Yes, can you solve questions of rules? Yes, I will solve. I will come there. Don't worry about that. So I will go page by page. So I will also solve from that page that Rines is asking right now. Okay? Aha, she wants me to solve from there because she wasn't here today. I understood. Let's not solve it in the video. Let's stop the video and solve it. I'm just joking, Rinesa. Please don't write that comments. Anyway, let's start from here. So this is like the second rule, which is square of first minus 2 first second plus square of second. The first thing, if you have some plural things in here like 5a, 7x, 6y, if you have something like that, you keep them with parentheses, 5a power 2, and then since it is minus, minus 2 times first times second one, and plus square of the second one. When I wrote squares, I used parentheses, but I didn't use in here. You may also use parentheses in here, it's not a problem. So now, if you have all in parentheses and power 2, there is no comment over that. Why are you smiling? Why are you? So 5 power 2 is 25 and a power 2 we write. We take power 2 of both, each of them. So that in here we should multiply the numbers firstly. 2 times 5, 10 times 7 is 70 times a times b, and plus take square of both of them or each of them. 7 squared is 49 and b squared. You are done. It is like two-step question, but it may worth 10 points in exam. So this is something similar. With the cube, you need to memorize the cube rule. You must memorize the cube rule. Let me write the cube rule once again. What was the rule with the cube? A cube. Then if it is plus with plus, if it is minus, minus in here. So then 3, we should start with 3. Decrease power of A, increase power of B. So then both of them will be plus plus, and 3 decrease power of A, increase power of B, then plus minus B power 3. If there is minus in here, you start like plus minus plus minus. Every time the first is plus, then you continue. If there is minus, plus minus plus minus, like that. So by looking that rule, you will open those cubes in here. Naive type of examples. Should we solve something like this? I'm so tired right now. Let's solve the last one. What is that, the time? When do you go to eating? Dinner? 6, huh? So, there is 6, no problem. For what? Libyan, huh? Okay, you go to Libyan. I solve the Renaissance question after you go, of course. So then if there is anybody else asking me a question, I continue to take the video. If there is nobody else asking me questions, I stop the video. So I like, till you go, I like to go, I want to continue page by page. So right now here we have types of examples. These are all the same types. Here we have, you see that I want to find squares. But there is given some of them, difference of them, something like that. So we should work with the given things. Take power 2 of both sides. What is the power of power 2 of this one? Power 2 of this one. So I am taking all in parentheses and power 2. Then you open this, x squared minus 2xy plus y squared. Then this one comes in here. So I want to find sum of x squared plus y squared. So I don't want minus 2xy in here. So I put it other side. Minus will be plus 2xy. X squared plus y squared. To find sum of them, I have one unknown in here. What is x times y? Look at that. The teacher gave it to you. Don't worry about that. So x times y should be equal to 6. Let's put 6 in here. It should be 2 times 6. What is 2 times 6? 12 plus 9, 21. You found the answer. What an easy question. So these are similar things. Only in the middle part, these A things will simplify each other. In the middle part, you will have minus 2 times 3A times 5A. This A and A will simplify each other. So you will have 2 times 5, 2 times 5 is 10, times 3 is minus 30. You will have in the middle part. Later, you will put it to the other side. Then in the beginning, there will be 3a power to 9a squared. At the end, 5a power to 25 over 8 squared. So this is the next type of factoring things. The first, so let's solve one question from each type. How many more minutes do we have? Yes, we have enough time. So the types of factoring is very important. The first type of factor, or first type, the methods of factoring are important. The first method is common factor method. We should try this method at every time. So, do you see something common over there? 20 and 15, 5. Then letters, the smallest power, x squared. You put the common thing out, then write the remaining things. 5 times what makes 20? 5 times 4. So then x squared times what makes x cubed? X. You put it inside. Or you can think like there is x cubed in here. If you put power 2 out, power 1 stays inside. So there is 15 in here. 3 times 5 is 15. So 5 goes away, out, and 3 stays inside. So there was x squared, all of them out. This is the first type, common factor. First method, sorry. Now, is it still the first method? I think yes, it is still the first method. Look at that. 24 we can divide by 4, 14 by 4, 16 by 4, 56 by 4. I think also by 8 we can do them all. 8, 8, 8. So firstly you put 8 out, later you try other things. So is this the second? This is the second method. So the first method, works for everything. Even if you have two terms, even if you have three terms, even if you have four terms, the first method, common factor, taking common factor out. Look at that. I have here one, two, three, four things, but from all of these four things, all of them has the factor 8. So I can put 8 out from everywhere. Here I have one, two, three things. So all of them has the factor 4, so I can put the 4 out. After putting 4 out, we try that can we continue in inside part? Can we factorize the inside part one more time? So now let's go to the next page, which is right now we have three more methods by looking number of terms. This is the method if there are four terms. There are four terms. If there are four terms, you group them. Do we have any interesting question? These ones I didn't solve in the class. So let's solve one from here. Let's solve this one. So first and second terms, these two doesn't have anything common. Let's find something has some common. Let's use this. First and third, I'm gonna put a out. So what remains? Y and plus 2x squared in there. You see that? I put a out 2x squared. So then I should do second and the fourth. If I put just b out, so as positive b, there will be minus 4x squared in there. Also look at that. There's also 2 in here, 2 in there. If I put plus 2b out, it will be better. Instead of 4, minus 2 times 2 is 4, and x squared should be there. And when you put minus 2b out, there will be minus y in there. There is the problem right now. Inside the parentheses, y plus 2x squared. Inside the parentheses, minus 2x squared minus 1. So that means we must also put this minus out. That's why I don't even start with plus 2b. I start with minus 2b. Let's check that. Minus will go out. That means there will be something positive inside. From 4, we will put number 2 part out, so there remains 2 in here. So b is going out, and then x squared is staying inside. From the last one, minus is going out, so that must be plus between them. So 2 is going out, b is going out, so just y is in there. So right now, check that. Do we have exactly the same things inside the parentheses? Right now, yes, we have. So 2x plus y staying, we put it out from everywhere. So from first place, just a. From second place, minus 2b. This is the second method. This method only when there are four things. Whenever you see four things, try to group them 2 by 2. So now the next method, when there are three things. When there are three things, we have two subtopics. If there is no number before x squared, you try two things. Their product is 18 and their sum is minus 11. Whenever you find those two numbers, you factorize it. What? We have a new comment. But if there are three terms, two of them have similar elements, but one term doesn't have same element. So it will be something like where in here. So these two has like 2 and 2, the common factor. When there are three terms, firstly we look for, do they all have the same factor? If they don't have same factor, all of them, we don't try the common factor thing. We try the three terms method. Three terms method, which is x squared. I need to find two numbers. Their product is 64 and their sum is 10. Guess what numbers can they be? So then about these three terms, we have the second thing. What if there is another number before x squared? Let's go and find something like that. An example like that. Did I remove it? I forgot to put it in here. I forgot to put it in here. Luckily, I am making this video in here. So, let me write a question for you right now in here. Let me make a question. So I'm going to add those type of questions. 2x squared, let's say in here 6 minus 11x, let's say. If there is a number even before x squared, that means this is also with three terms, second method with three terms. You also separate this one as product of two things. You also separate this one, it was I think 6 and 1, I have arranged. So then, to make it minus 11, 1 times 1 is 1, 2 times 6 is 12, 12 and 1 has a difference, 11. So to make it minus 11, big product should be minus, small one should be plus. So you show it to teacher in here, 1 times plus 1 is plus 1, 2 times minus 6 is minus 12, and they both makes minus 11. So then we can factorize this expression as first row, 1x with minus 6, and then 2x with plus 1. And it is done. So the three terms is finished. Firstly, we started with 4 terms. Now we did 3 terms. With 3 terms, we have 2 subtopics. What if there is no number in here? What if there is also a number in here? So now we are going to do with the 2 terms. If you have 2 terms, did I forget that one also? Add that one in here. I also forgot that one. I think it's because of the savings. I skipped one saving, one lesson. Also, let's check that one from where? From here. Let me add a page in here. When there are 2 terms, we have 3 rules to memorize. 3 rules. It can be difference of squares, it can be difference of cubes, or sum of cubes. You must memorize these three rules. If they have minus between them, a squared minus b squared, this is the one which we use most. Even today we use a minus b, a plus b. So if they have minus between them, a minus b. If they have plus between them, a plus b. Something like this. You can make the rule in your mind like that. You have minus, start with minus. You have minus, start with minus. You have plus, start with plus. Always start with the same thing. If there is minus square of them, the next one will be a plus b. If there is cube of them, the next one will be, since it is cube, we use one power in here. There should be also a square in here. So a square plus, not to ab, just ab. Be careful about that, just ab in here and plus b squared. Because this minus will affect the rest, but right now since we have plus, we should use the minus in the next one. A squared minus ab plus b squared. It's kind of like that. If you use minus in here, you should use all pluses in next. If you use minus in here, you should use all pluses in the next. If you have plus in here, you should use minus in the next. Kind of like that. So here is the question of this kind of things. Like what? Let's find one. X squared minus 9. We have 2 terms in here. So should I use the square rule or cube rule? So since we have x squared, that means it is square rule. So since 3 can be shown as 3 square, 9 can be shown as 3 square, it's simply x minus 3, x plus 3. Or if I put, yes, there is a comment, yes. The voice is stopped. Let's check that one. Is it working right now? It should work right now. Yes, it is working right now. Oh, liar. Okay, the voice is working. Let's move on. And this is the last method since it is past why? Past 5 o'clock. So with the cube, let me show you an example with the cube. Let's make it very hard example. Oh, Oran, can you tell me? Let's cube of what? Cube of which number? Let's write cube of 5. So let's say I asked you to factorize this in exam. Let's say 10 points, but this wasn't 10 points. Yes, if I ask this, this is like ABC. This is maybe like 3 or 4 points. So you look for, there are two things. First thing, is there anything common factor in here? No, no common. So if there are two things, two terms, we should do with this method. So should I use square thing or cube thing? Since you see the x cube, I must make it all in parentheses x cube, all in parentheses cube. I should do that. So 8 is cube of which number? 2. X cube is already in here. 125 cube of 5. So then use the rule from here. What does the rule say? If you have a cube minus cube, b cube, like first and second. First you write them with the same sign, without any power. The first is 2x minus the second is 5. So after that, since I used minus in here, the rest will be all with plus. And I used power ones in here. So that means power 2 of first, and then plus first times second, and plus power 2 of second. You just need to continue one step more. 2 squared is 4 and x squared. 2 times 5, 10x, and 5 squared is 25. So right now, the people in here, you may go. I think it's time for you to go, but actually, I don't want you to go. If you want to go, you go. It's okay now. Aha. I think, which one that, Miran? Your laptop or your phone, whatever you are listening with, probably may have stopped, not the voice in here. Yeah, my tools are working good. So, see you, okay? You can see in Tutum, but I will not be solving everything. I will be solving whatever they ask me. So right now, Ait and Rinesa, I think you are in there right now watching, and Edison is leaving. And Rinesa asked me about the last part. I will go to the last part right now directly. Also, bye. See you guys. Ait, if you want to ask something, you can write it in comments part. You can also write the page number. So right now I will be going to the last page that part Renessa wasn't here today. Let's move that. So I forgot to add those parts. These are the questions that we solved today. Renessa wanted to hear about them. So can I see which people are connected? No, I can see it from here. So enough. This part is for Inesa. I hope that she is listening to us. So Inesa, this is something very simple, which is right now we will be working with the roots. So we will write a quadratic equation. So x squared minus sum of the roots times x plus product of the roots is equal to 0. Such that equation will be written. Since we are using these roots, sum of them minus 1, positive 5, 4. Product of them minus 1 times 5, minus 5. Put them in here. X squared minus sum of them is 4x. And plus times minus 5, that will be there, but let's write directly minus 5. So then the next one, since it is exactly the same thing, I should find sum of these two things and product of those two things. So 2 plus root 3 plus sum of them, 2 minus square root of 3. 2 plus 2 makes 4, positive root 3, negative root 3 makes 0. This is the sum. So then product of the roots, 2 plus square root of 3 times 2 minus square root of 3 equals. This is something like that a plus b times a minus b, so it's going to be a squared minus b squared, which is 4 minus square root of 3 squared is 1, so 1 is the product. Let's write the equation. X squared minus sum of the roots, what's that? 4x, and plus product of the roots is 1 equals 0. So then one more question that we did today. Is there some more questions in here? Aha, we did 2 more, yes. If it's right that only root is 1 over 3, that means normally we used to show the roots like x1 and x2. That means it's going to be same. We also can call it like double root. So sum of them 1 over 3 plus 1 over 3, and product of them 1 over 3 times 1 over 3 is 1 over 9. Let's put them in the equation. X squared minus sum of the roots is 2 over 3x, and plus the product of the roots is 1 over 9 equals 0. Here we have an equation. If you try to solve this equation, the roots will be only 1 over 3. So I wrote from Vieta's theorem. Okay, after I finish this part, I will go back to there. So then, here we have 2 more examples about sum of roots or finding the equation. So whose roots are 2 more than the roots of this equation. That means first I should solve this equation. Let's factorize this one. I need 2 numbers, their product is minus 8, and they have the difference 2. Since it is negative, I look for their difference, so their difference should be 2. Since one of them is going to be minus, later I'm gonna put. So now let's think about where to put the minus. Since I need minus number in here, minus result in here, so the big one should be minus, small one should be plus. So then we can factorize this as x plus 2 and x minus 4 equals 0. So here we have 2 paths to continue. X is equal to minus 2, x minus 4 is equal to 0, x is equal to positive 4. So these are the roots of this equation. So we should find need equation whose roots are 2 more than the roots of this equation. 2 more of these. So 2 more of minus 2 makes 0, the first root. Then 2 more of 4, 4 plus 2 makes 6. So right now we should write need equation with these roots. These are the need roots. I should write an equation with them. First is sum of them. 0 plus 6 is 6. Then product of them. 0 times 6, 0. So x squared minus sum of roots plus product of roots equals 0 is the 4. I can use. Minus sum of roots is 6. And plus product of roots is 0. So I did use 0 in here to show you, but normally we can continue one step more and remove that 0 from there. And we cannot remove this 0 since it should be equal to a number. A number has to be in here, so we write that 0 over there. Now the last question about this finding equation. The roots of the equation, here we have an equation, x squared minus 4x minus 12 are x1, x2. So let's solve that one and find x1, x2. X squared minus 4x minus 12. The roots of these will be x1 and x2. So we can factorize this one with, since it is a negative number, the possibilities, we will take difference of them, 2 and 6, and the difference 4. So now it should be minus 4. Let's put the minus for the big number, plus for the small number. So their product is minus 12, their sum is minus 4. These are the right numbers to factorize it. Equals 0. 2 ways to continue. In the first way, what if the first part equals 0? We are going to find the root like minus 2. And the second one equals 0. So that means x is equal to 6. Here, we can call them as x1 and x2. And there is an idea in this example. So now, let's move from here to read. Find the equation whose roots are x3 and x4. So now I'm going to find x3 and x4 such that x3 equals 2 times x1 plus 1 and x4 equals 2 times x2 plus 1. Right now, I did use x plus 2 in the beginning, so I found x1 as minus 2. But when you solve, you may use x minus 6 in the beginning. You may find x1 as the positive 6. Because of this reason, the two rules in here, they must be exactly same. When we ask the question, they will be. You be sure about that. They will be exactly same. Because some people may use that 6 as the x1, some people may use like minus 2 as x2. That's why they should be exactly same. So now, let's find the new roots with the ideas. x3 should be equal to twice of x1 and plus 1. Twice of x1 is minus 2 and plus 1. 2 times minus 2 is minus 4 plus 1 makes minus 3. Then x4 is twice of x2 plus 1. 2 times 6, 12 plus 1 makes 13. So I have the new roots to work with. So I must write the equation. Find the equation is the problem. So to write the equation, firstly, I should find their sum. 13 and minus 3 makes 10. Then their product, 13 times minus 3 makes minus 39. So let's set up the equation. X squared minus sum of the roots is 10x. And plus product of the roots is minus 39. Plus minus 39 will be minus 39 equals 0. I didn't want to do two steps in here. I did it directly. So this was the last question on PDF. Also on this PDF, I forgot to put one part which is with the x squared starting like 3x squared and then the two-term part. I will add those parts after this YouTube video. So now, there's one more person left, which is probably I hope. But for you, I will continue, whoever it is. So you wanted me to go back to Vieta theorem. Let's go back to the Vieta theorem. These are very good questions. I love them. This one, for example, is very good question. Yep, I think. So this is not Vieta. Yeah, this one. So Vieta's theorem says that even if an equation, a quadratic equation, even if it doesn't have roots, we may talk about sum of the roots and product of the roots. And we have the clear way to find them quickly. What are these ABC things? A x squared plus bx plus c. So what is the sum of the roots? If I ask you that question in here, minus b is 6 over a is 2 minus 3. So then, what is the product of the roots? C over a. C is 5, a is 2. So 5 over 2, 2.5 is the product of the roots going to b. Even if you are not able to do it in real number sets. So these are the first two examples about finding them. So now here we have some kind of examples working with them. So now, if I am asking you things about the roots, that means you need to use your also kind of ideas here. X1 plus x2 squared. I have given you the formula of it, but let me write one more time. It will be related with x1 plus x2 squared, and then when you open x1 plus x2 squared, there will be the middle part, which is plus 2 times x times x1 times x2. So we should remove it from here. So these two things can be equal over there. When you open this one, there will be the mid part. Let me repeat one more time. Plus 2x1, x2. You are removing it in this place. So this is going to be related with x1 plus x2 cube. When you open this one, in the middle part, you will have two terms, starting with 3, starting with 3. So we should remove those two terms. What are those two terms going to be? x1 squared, x2, plus x1, x2 squared. So let's factorize. We should remove these two from open form, so we can find only sum of cubes, not the mid part. So we factorize these two things as x1, x2. So inside the parentheses, from first just x1 remains, plus from second x2 remains. This is the way that we find the formulas. So now, solving this one. Also in here, you should make the denominator same. So x2 over their product plus x1 over their product. So x1 plus x2 will be in numerator and their product will be in denominator. So from this example, A, B, C numbers and their sum x1 plus x2 is equal to minus b over a minus 3 over a is 1, so just 3. And product of the rows c over a, which is minus 2. You will just put them in here instead of sum and product. The sum is 3, the product is minus 2, you finished. In here, the sum is 3 over 2, minus 2 times product is minus 2. So 3 minus minus will be plus 4, 13. And in this one, their sum is 3 and cube will be there, that 3 times their product is minus 2 times their sum is 3. 3 cube will be 27, minus minus will be plus. 3 times 3 is 9, times 2 is 18. Actually, it is going to be, so 27 plus 10 more, 37 plus 8 more, 37, 44 and 45. I think it will be. So enough. Let's check the comments. So I will do 1 and 2 more examples about this with Vieta. Later, I will check that. Do you want anything anymore? So in the class, I have skipped one example. Let's find that example. I have skipped it today. Let's find that one and solve that one. In the class, I just skipped one example. I think it was this one. But this might be unnecessary. Did I solve this in class? I think I did solve this one in the class. These one symmetric roots I did solve in the class. These are like working with some of those. So let's come to this one. This is so unnecessary question. Let's solve something that I have solved in the class one more time. This one looks so mixing. Let's solve this one. So let x1 and x2 be the roots of the equation and given over there. So there is a relation about x1 and x2 is given in here. So we should work with x1, x2. We should work with them, and at the end we should find them and the value of. How can we understand that this is a problem about Vieta? So we should work with the roots, and we are not able to find the roots directly because of the n. So that's why we should figure out another way. So we say that sum of the roots is minus a, b, c part, all of them, minus b over a, which is minus 2, and product of the roots c over a, which is m minus 1. So I look for, can I use sum and product somewhere else? There is something else is given in the example. 2 times x1 can be written like x1 plus x1 plus x2 equals 6. So here we have some of the two roots. I am separating 2 times x1 into the like third grade question, like 2 times 3 is 3 plus 3, something like that. So then x1 plus x2, sum of them makes minus 2. We already know that. So since this should be equal to 6, we can find the value of x1 as minus 2 will come here as plus 2 and 8. So now we know the value of x1. We know that sum of the roots should be minus 2, which is x1 plus x2 should be minus 2 from here. So we found one of them as 8 plus x2 should be minus 2. If you put 8 other side, it's going to be minus 2 and minus 8, which is minus 10. So we found x1, we found x2. It's time to find the m. What does it say? Product of the roots, which is 8 times minus 10 should be equal to m minus 1. We connect those, which is minus 80 equals minus 1 will come here as plus 1, and m in here minus 79. It's a very good question to ask in exam or quizzes. Do only 2 examples and enough. Okay, you don't want any more. So I did one. Let me choose another. Seems hard to me, not to you. Let's look for this one, the product of the roots of the equation. Is 2. It's already starting like product of the roots. So you can understand that it's about the Vieta. It's already starting like that. This one I thought so it's unnecessary. I didn't even skip it in the class. This one may be important, maybe, may not be important also. Symmetric roots, no, it's not so big deal. So let's solve this one then in the beginning, the one in the beginning. So let's do this one. Since it is talking about the product of the roots and giving it directly, so you clear the ABC things from here. So then you start with the product of the roots. x1 times x2, the result. First, let's write the formula in here. Should be C over A. So the result of this product must be number 2. It is given in the example over there in here. So product of those, the part C is all of these without x, k plus 1, k plus 1 over the part A is 2k minus 1. So we should solve this equation. That's why we write over 1 and do the cross product. 2 times 2, 4k. 2 times minus 1, minus 2. 1 times k plus 1 is k plus 1. So we want to find the k, so this is the smaller. You put it other side as minus k. Minus 2 comes here as plus 2. Plus 1, we keep it in here. 4k, we keep it over there. So 3k equals 3k equals 1. Let's check that. Was it the question finding the k? Find the sum of the roots. They want us to find the sum of the roots. Sometimes when you find the value of the k, you think that it is finished. Be careful about that. Go back to question and check it once again. I want you to find the sum of the roots. So let's come here. Sum of the roots, Vieta's theorem. What was that? Minus b over a. Let's write those things from here. Minus b is 3k over a is 2k minus 1. So form k as number 1. Let's replace it in here. Minus 3 times 1 over 2 times 1 minus 1, which is going to be minus 3 over 1. Minus 3. So you may go back to the PDF of the questions and check that is there any other example that you want me to solve. Right now I can solve them all. It is not so problem for me. As you wish. I will wait like 1-2 minutes more, then I turn it off. Close the video. And you can write it with comments, that one.
Okay. You wrote that it's enough, so see you. I hope that the other people who didn't watch the video can do good in exam. Good evening. It's so late in the night. Late in the evening, not night, of course.